Hello and welcome and happy Valentine's Day. This is going well, I think, with David Cooper, and I am David Cooper. You know, this is the only show where no one's listening, no one cares, the show where every episode's the last episode. Today we're going deep into outer space. Ooh! To talk about how NASA has discovered a potential super Earth that's habitable 137 light years away. I have with me Professor Sarah Rugheimer. She's an astrobiologist, an astrophysicist, and the Alan I. Carswell Chair for the Public Understanding of Astronomy at York University in Toronto. She's the author of Searching for Extraterrestrial Life. That's an Audible original you can find on audible.com. Now let's talk super duper super Earths and the potential for extraterrestrial life on them. Professor Sarah Rugheimer, welcome to the show.
Thank you for having me, David.
I've seen a lot of videos of you where you talk about whether we're alone in the universe. I don't think we are, but I still do wonder why I'm so lonely all the time. But I think that's a problem for my psychiatrist. But let's start here. There are some asteroids, including one the size of like a football stadium, expected to pass Earth soon. I have seen the very real documentary Armageddon, so I know what happens. I'm kidding, of course. Is this something to be worried about?
No, and I mean, these sizes of asteroids, while they would cause potential devastation depending on where they land, similar to the one that landed in Russia, they aren't so big as to cause like global catastrophe in any sense of the word. So these are relatively small. They're also not, they don't have any chance of actually colliding with Earth. They're far enough away. And we do keep track of asteroids that could potentially cause harm. So these are coming close, but, you know, there's a lot of asteroids in space, and some of them come close. Some of them, unfortunately, hit us. And every, few 100,000 years to tens of millions of years, you'll get a much bigger one.
Yeah, just ask the dinosaurs. But when you talk about Russia, is there something more recent?
It is, but it's not like dinosaur extinction level scary. So I think we need to kind of sort out what these are in terms of how scared should we be. 70% of Earth is oceans. Most of them are going to not impact a city, right? I think we think of movies like Armageddon, it's coming straight towards Toronto or New York or whatever. And that's very unlikely. It's usually going to impact in an area where there aren't people. It's usually going to interact maybe in a desert, impact if it does. And so while there's a chance for those smaller size asteroids to cause local devastation, they aren't the ones that we really worry about, which are the dinosaur extinction level asteroids. That's your 10-kilometer sort of asteroid. And that would be worth freaking out about. That's the Don't Look Up movie analogy that was for climate change, but also, about the asteroid coming towards Earth.
And then there's that movie Melancholia, where the planet just appears out of nowhere and impacts Earth. But okay, how about this one? Do we have an accurate picture of all the asteroids out there? Like, do we have these things all mapped? If there is a 10-kilometer wide asteroid that could potentially impact Earth, do organizations like NASA have a clear picture of when? Or are there just millions, billions, trillions, who knows how many objects out there that we just don't know that could hit Earth?
Yes, I mean, basically, there are bodies that look for these minor objects, as we call them, and they will, of course, know about the ones that are bigger more easily. Those are bigger, they're easier to observe. Those are also the ones we care most about because those are the most dangerous to us. And as you go towards smaller and smaller asteroids, we just aren't able to see them. It's like looking for a dark rock on a dark night millions of miles away. You can imagine this is not the easiest thing to see. So we do prioritize looking for asteroids that could cause actual real devastation to Earth. That's our first priority. Those are well mapped out. So the extinction level event asteroids, we have a very good mapping of those. None of them are coming towards Earth. But there is a reason for us to put effort into trying to figure out what to do if one of them were to come towards Earth, because that's the sort of thing you would want to know about, decades away to do something about, rather than like, I don't know, a few months away, we would have no chance of doing anything.
And what would we want to do? Fly out there, land on it, figure out a way to alter its course, or blow it up into two pieces that wouldn't hit, or something like that?
Exactly. So that was the DART mission. I think it was just last year that NASA sent to redirect an asteroid and basically collided something like a refrigerator into the size of the pyramid, one of the Great Pyramids, and showed that that shifted the course of the asteroid a bit and changed the orbital dynamics. So, if you can do this far enough away, and you can just give it a little nudge, then great. It's no longer going to be on a collision course for Earth. So again, you need to know those things pretty far away in order to be able to do anything about it. But that was the DART mission. It was a wild success. And so we are just now about reaching the technological sophistication to be able to avoid utter and total devastation from an asteroid. And, I'm hoping that by the time one actually appears in our skies that would be devastating, we'll be able to take care of it. But these more minor ones that are smaller, those are often we don't see them far in advance, but they're not going to cause a lot of devastation. So it's, just kind of the risk of being a sentient species on a planet orbiting, a small star in the galaxy. Like there's just not a lot you can do sometimes for the smaller objects.
So it's my parents' fault, my Jewish mother's fault for bringing me into this world knowing that risk.
Guilt.
If we figure it all out, let's say in the next 10, 15, 20, 50 years, how to alter an asteroid's course, the good news is we're only at risk of destroying ourselves, not an asteroid destroying us, which would obviously never happen because the political situation on this planet is fine.
Yeah, I mean, you're totally doing well right now.
So speaking of the political situation on this planet, NASA has discovered a super Earth, 137 light years away, which is potentially habitable. It's in the habitable zone of its star. This thing is called TOI 71b. And I know 137 light years may seem like a lot to people, but I think that's pretty close on like a cosmic scale. For me, that's like as close as my upstairs neighbor who's very loud at 3 a.m. when he does, like, I want to say gymnastics with his girlfriend, but I digress. Tell me about this discovery. What's so exciting about it? I know we found other planets before. What makes this one so exciting?
Yeah, I mean, I think this planet is not uniquely exciting. It's just yet another example of a habitable planet close to us that we want to learn more about and see if it actually does have life. So there's a few things that often come to mind. You mentioned the distance, it's 137 light years. Sure, on the scale of our galaxy, that's 100,000 light years, in diameter, that's very close, very close. At the same time, it's so far, we're never going to get there. If we think about the furthest object we've sent from Earth so far, Voyager probe from, way back when, like over 40 years ago, that has only gone roughly one light day from Earth in that amount of time. And to even get just 4 light years, it would take 70,000 years. So we are not getting to this planet at any point.
Yet.
Yet. We need to have warp drive or something.
Either that or figure out intergenerational space travel, right? Like we get close to the speed of life and then we send 2 or 3 generations of people out there.
But remember, 4 light years, 70,000 years of travel. So going 137 light years, you're talking, like what, hundreds of thousands, if not, a million or so years. That's like more than humans have been around.
But I'm saying we get faster engines is all.
It's more expensive to accelerate more massive objects. I don't think we're getting there.
Okay, you know what? It's almost like you have the education and I'm just some idiot with a microphone.
It's a great idea in sci-fi, and I hope someday that we discover something that upends our physics. But right now, we're not getting there. So these objects are, to me, as an astrobiologist, this is my area. This is my wheelhouse. I study how we could detect biosignatures in the exoplanet atmospheres. This is definitely an object of interest that we're going to want to follow up. We're going to want to see if there is an atmosphere, if there's signs of life in that atmosphere. And that, to me, is why it's exciting, because we don't have any robust evidence of life outside Earth. there, for all the talk of UFOs, none of those have actually panned out to be robust, evidence. And so actually finding out if we're alone in this universe, I think we're going to have to look for it. It's not here, it's not coming to us that we know of so far. So that's why I'm excited about these objects. Is let's look in the atmosphere. Let's point our telescopes, see if we can tease out those signs of biology. And that would completely change our view of how common is life in the universe and what our place is.
So I mentioned earlier this planet was in the habitable zone of its star. What is that? What exactly does that entail? What makes that different from a planet that is not in a habitable zone?
Yeah, the habitable zone is the distance from the host star where liquid water can be stable on the surface of the star. So what does this mean? This means that at the inner edge of the habitable zone, right around there, that's when you start, boiling off your oceans. And at the outer edge of the habitable zone, no amount of atmosphere and greenhouse gases could keep that water stable. It would just freeze out. And so that's a ring, an annulus around the star where liquid water could be stable on the surface. Why do we care about the surface or liquid water? We can go into that, but basically, just because it's habitable doesn't mean that liquid water is on the surface of that planet. It might not have an atmosphere. It might have the atmosphere that maintains habitable conditions. It's just that we know that it could. So it doesn't mean that it is habitable. It just means it could be habitable. And that's sort of the first step to then determine, is it habitable? And then indeed, is it inhabited? Does it have life? Does it have signs of microbes on the surface?
What's the best evidence we have right now for life on other planets? Is it just that planets exist in this zone, or have they detected some signs of life?
We've not detected any robust biosignatures yet. So there is, again, no evidence of life outside Earth. There have been some claims, for example, the Martian meteorite in the 90s, that hasn't panned out. There was the claim of a phosphine on Venus as a potential biosignature. In the news recently, there was also dimethyl sulfide.
Yes, I remember covering that a few weeks ago. From my vantage point, that was pretty good evidence, but what panned out to be wrong with that?
It hasn't been proven, right? So they found a very preliminary detection that isn't even a publishable detection at this point. So given how they analyzed the data, what they're saying is, there is a chance that there's dimethyl sulfide. They did not claim that there was dimethyl sulfide. So Niku Madhu-san at Cambridge, he was very clear about that. Madhu said, look, we need another year of data with James Webb to be able to figure out if this is dimethyl sulfide. Then, if it is dimethyl sulfide, which we don't even know yet, we need to wait a year. If it is dimethyl sulfide, is that life? We don't know, because this planet is hydrogen rich. It's a different sort of planet than Earth. And potentially you can form hydrogen rich compounds with which dimethyl sulfide is in a planet like that without life. So there's a lot of research that still needs to be done that is not a detection of life outside our planet.
Got it. Why it was so exciting for me is from what we know on Earth, which is one set of conditions, this chemical only exists because of life. And that's why people were getting so excited about it. But A, we're not even sure it's there, is what I'm hearing from you. And B, even if it is there, the conditions on the planet could create it without life.
It's a very different sort of planet. So we don't yet understand the type of planet that is, and it could be that those molecules could form without life, yes, as well as, sure, like as you said, the lead authors of that paper themselves did not claim that this is a detection of dimethyl sulfide. They just said it could be there. Like the data is consistent with it being there, but the error bars are so big, the detection signal is so weak that we actually haven't detected it. So I think that was maybe misrepresented to you in the news.
Of course, misrepresented to me and then misrepresented by me. And then I was using it to contrast the hearings in Mexican Congress where they unveiled the quote-unquote aliens that ended up being probably Peruvian, or was it Peruvian artifacts? There was something ugly going on there where they stole like basically mummies.
Yeah, none of these panned out, sadly. I mean, and I want there to be life. Like I will, if I find a robust detection of life, let me tell you, you'll know about it. I will be shouting it everywhere. We just haven't yet found that robust detection of life.
I just regret at that time saying we actually have good evidence and not what's going on in Mexican Congress. And I was obviously wrong, but honestly, that will surprise nobody. What are you most excited about study-wise? So this is your wheelhouse, your area of interest. Are there specific things that James Webb, the telescope, is going to be looking at that you're excited about? Are there other things, other findings on the horizon? And also, where are you putting your efforts?
Yeah, so I think James Webb is not going to be able to answer this question for us ultimately. I think it'll be able to observe a few habitable planets. If we're really lucky, maybe we'll see really good signs of life. But James Webb is mainly going to be detecting Neptune-sized objects, Jupiter-sized objects. It's just not big enough to do the Earth-like habitable size objects, or it'll detect lava planets, closer in planets, stuff like that. But it can detect like 6 or so habitable Earth-like planets. And if we're super lucky and life exists in a strong way, global biosphere on those, maybe we'll have found life. So that might be depressing to some. So that's why I'm working on the next generation telescope. So there's 2. There's one that NASA has selected, which is the Habitable Worlds Observatory. And there's one that I'm on the mission team of in Europe called LIFE, the Large Interferometer for Exoplanets.
I love the what is that called? The backronym where you start with what you want.
Oh, for sure.
You start with a silly acronym and then you design the title of it to match the acronym.
Absolutely. And indeed, that's our whole mission is we are a team of scientists and we are driven by one thing. We want to find aliens before we die. We think this is the best telescope to do it. And so that is where I spend a lot of my scientific and more like political efforts to try to get excitement and funding for this telescope. So I think those will be the ones that give us the answer, unless we're super lucky with James Webb. But because it's at the edge of what James Webb can do, the signal is going to be controversial. People will be arguing about it. It's going to be like the Martian meteorite, where you're just going to have probably a lot of back and forth debate, which will increase our understanding and is a vital step of this process.
It's pretty interesting. So it's not so much findings on the horizon as it is telescopes on the horizon for you.
Yeah, absolutely.
Cool. And what do you think life will look like when you see it? Or is that the thing? You have no idea?
No idea.
What if they're better looking than us? And we're all kind of ugly compared to them.
Hopefully one can imagine it opens up our dating pool, but most of life is going to probably be microbial, even on Earth, even you and me, we're, 1 trillion human cells and about 1 trillion microbial cells. So we're equal human and not human. Are we really human? Like what does that mean?
I'm going to go wash my hands. I'm freaking out. It's fungus all over my skin. Yeah, I don't want to talk about it. No, please keep going.
Yeah. So, microbes dominate the biosphere of Earth, and that's what I expect we'll find. And we'll find things that are using the same chemical energy pathways that just exist in the universe, that are part of chemistry and physics. But that sort of definition precludes AI sort of life. And it's very possible that, general intelligence AI, should it exist, actually is the most dominant form of life. And that wouldn't be chemical. That's in the science fiction realm. There's a great 2-page story by Terry Bisson called "They're Made of Meat," and it's basically around this concept where AI life is looking at us and they're like, "But they're made of meat. We can't interact with them. Like, where are their silicon connections and their electronics? They can't be that smart. Are you telling me these meat objects put telescopes in space? That's insane." And maybe that is true. Maybe it's not. We just don't know.
Before I decided, as my mother says, I hated money, I studied computer science, and I was at the University of Toronto, and I was very interested in this thing called the tech singularity, which we may or may not be on the horizon of, and it's when AI gets so good. I think the best way to describe this to someone is AI gets so good it's able to improve itself, and once it's able to improve itself, it'll reshape society in unimaginable ways. As unimaginable as what alien life might look like. Will that happen? Won't it happen? Is the AI that we're seeing now just, smoke and mirrors, or are we on the precipice of something? That I don't know. There are people who think we are. And when that happens, and if it takes over life on this planet, it becomes a dominant form of life, then that's what we can expect to see out there, which is kind of scary. But maybe it'll like us. I don't know. Maybe it'll be a benevolent.
I think we look at this all in human terms, and there's actually this really great book. I don't know if you came across it. It's a sci-fi book called Blind Sight. I think it's Peter Watts. I don't know if you've heard of it. But it was written in 2006, and it's as if ChatGPT is the dominant form of life in the universe, where it's not sentient, but it's intelligent. So we tend to associate intelligence with sentience.
Well, in reality, sentience can kind of make intelligence go awry. Like, that's our bias is Like it's what can get introduced into science to make things like look ugly, like bad studies, opinionated studies, where we've got a religious conclusion. But sorry, I'm derailing here. Please go on about the book.
So the point is, like, what if intelligence is actually not sentient and you're just interacting with something that's able to mimic to you based on what it's learned from you, but it's not actually aware of what it's saying, but still acts in intelligent ways and even destructive ways, but there's no morality, there's nothing there that's kind of volitional. And that's also possible. And that's really outside our scope of what we usually think about when we think about intelligence, and certainly alien intelligence. But we just don't know. And it's a great book. I recommend it. And it has a lot of these ideas in it.
Cool. I'm trying to remember the name of this movie where a sort of cube lands on Earth and this team of scientists go in the cube.
Isn't it called The Cube? And it's a horror movie?
No, I that's a separate movie which I did see, but this one, it's this weird biosphere and it comes in and it alters life, and at the very end, the scientist confronts the alien and it's just like a mimicked version of her.
Oh wait, yeah, I think I saw that. And is that Katie Sackhoff in it?
Yes, I think she was from what?
Battlestar Galactica.
And also the weird cult. Nexium is that.
Oh, really?
Yeah, all the Battlestar Galactica people landed in Nexium. Isn't that wild?
I've been meaning to watch The Vow. It's on my to watch list.
What is that movie? It's going to kill me. You know what? Forget it. I'm not going to go down this road. We can end it there. Thanks so much for coming here.
Yeah, no, thank you. This was fun. And let's come back to dimethyl sulfide in a year or so.
Yeah, I was so excited about it, and I used it as such a strong contrast to what was going on in Mexico, being like, there is evidence, and this is what evidence looks like, and I'm glad that I'm just an idiot. I'm so much more.
It's as it always is. There's what the scientists say, and then what the journalists report, and then what the headline says. There's kind of a triple layer of making it more sensational, and that happens with pretty much every story.
And I almost forgot, you're also the author of Searching for Extraterrestrial Life. Do you want to tell me about that?
Yeah, it's basically, if you've watched my TED Talk, which is 5 minutes, this is the 5.5 hour version of that TED Talk. So it's how do we detect life? How are we sure that we've detected life? What's the uncertainties in that? What's the nuance? What is life? How did life evolve on Earth? All these sorts of questions. Where are we with exoplanets? And so it's a 10-lecture Audible series on Amazon Audible Originals. So it's not a book, but it's an audio series, like a lecture course on this topic.
Thanks for your time, Sarah.
Yeah, thank you so much, David.
Annihilation. The name of the movie is Annihilation. Yes.